Steve here for SSI. Welcome to the shop. Today I want to build a set of soft jaws for my Columbian vise, my table vise. So I have a piece of Teflon that I'm going to use for the soft portion of the jaw, and of course just some stock pieces of aluminum that were scrap here laying around in the shop. To attach it to the vise itself, I want to use these little neodymium magnets to magnetically attach it. I don't want these jaws to be a permanent portion of the vise, nor do I want to have to pull these jaws off to put on this other set. So I just want to be able to snap them on and off magnetically and use them whenever I need them, which isn't very often, but still yet I would still like to have it. Now in a couple of my other videos I've shown you that I've used a piece of wood, just a standard 2x4 stuck down inside the vise, and I've used those as soft jaws. They do hold threaded objects very well whenever you need to cut a piece of it off or whatnot. But a lot of the times if you have the jaws real far apart, say about so, you have to stick something in the bottoms down here at the same distance of the piece that you're clamping, or they'll just tip in, so they won't clamp anything. That kind of becomes a hassle from time to time. So I'll give you a quick rundown of how I come up with the measurements, and we'll start building them. So here's the tabletop vise that I want to build the jaws for. You can see this piece of material is real close to the size that I'm actually going to need, and what I want to leave behind is about 100,000ths of an inch on top of the jaw, so whenever it locks into place it's kind of like a piece of L bracket or angle iron. It just sits on top, but the magnets will be inside. After I mill this piece out, they'll actually be pocketed. There'll be one on each side. They'll be pocketed in, and whenever it goes on there it'll just snap into place. So there'll be about 100,000ths left on top. So the material I have is about 20,000ths of an inch wider than the actual vise jaw, so that gives me a little bit of room to do a peripheral cut on each side to smooth this out. There is a little step right here. I'll have to mill this off, and these pieces are not exactly the same thickness. The vise jaw is 965,000ths in height. The material I have is 1 inch 55,000ths in height. So I'll come up with, won't quite be 100,000ths, but it'll be pretty close, give or take. I'll leave that much material behind on top. So the depth of the jaw on top, I don't want the material to come back on top of these pins right here on top of the vise. There's 4 of them, 2 on each jaw. That's what actually holds the jaws into place, and it's 500,000ths from the edge of this jaw face to the edge of the pin. It's actually a little bit further, but 500 would clear it. So I want to leave that as an overlay or a lip on top to be caught. So after figuring out the distance, or the thickness I should say, of the magnet, which is about 1/8 of an inch thick, plus leaving 1/8 between the magnet and the pocket I'm going to make for the Teflon, the pocket for the Teflon will actually be 50,000ths of an inch deep, and I'll leave a 50,000ths border all the way around to help inset that piece of Teflon. So it'll hold it firmly in place and shouldn't let it slide any direction. So the overall thickness that I need for this piece of aluminum is about 800,000ths. This piece is 1 inch 20,000ths. So a couple of 100,000ths to mill off before I actually start pocketing it in, or cutting it in, then actually doing the pocket. But the first thing I've got to do is go ahead and mill all the heights and depths as far as the overall height and the overall thickness that I need. So I'll spare you those details, and before I actually make this pocket for sliding it onto the vise and drilling the holes, or actually I'll probably be plunge milling the holes into it for the magnets, then I'll do a pocket on the front to set the Teflon in. Okay, this is where I'm at. So I've got a chunk of aluminum with some rough dimensions that I've done some calculations with, and I've cut a couple of strips of my Teflon. Now what I've done is I've went ahead and I've cut a pocket into this piece of material already. So this edge that's left is 50 thousandths of an inch. I used a 3/8 end mill, so my radius is 187 thousandths, 5/10. And I've fit a piece of Teflon already into this one. So here I am at the milling machine. I'm getting ready to pocket this aluminum for my Teflon. Now the Teflon is 180 thousandths of an inch thick, so I'm going to pocket about 90 thousandths down, about half the thickness. That way I've got a good fit, and whenever I glue it in place I shouldn't have any problems with it ever moving. I'm using a 3/8 carbide end mill, and I'm just going to go ahead and plunge mill down into it, then just run it over to each edge, and I think that's going to be enough to take it all out. If not, I may have to run one through the center just to clean it up. So I'm just going to do it in one pass, and I think it should be okay. So it's a good snug fit. It won't fall out, and this should give me enough of a pad, because I went ahead and cut the pocket 90 thousandths of an inch deep for a piece of Teflon that is 180 thousandths of an inch thick. So my next plan of action is to go ahead and cut this chunk out, basically right here. So I have a little bit of edge left that'll land on top of my vise jaw, and there'll be enough thickness here that a couple of well-placed neodymium magnets pressed into this, just 2 of them probably is all I'll need, 2 on each one, that will lock it into place. That part will be showing right here, a nice machine surface. So once I get this piece cut out, then I can go ahead and spot mill a couple of sections or a couple of rounds for these to be put into. If I've got, I think they're about 7/16. So if I've got an end mill about that size, I'll go ahead and just pocket mill those in. Then I'll just stake them. I won't have to glue them or anything. And the only way I could really fit this piece of Teflon in here is to use a sander, just like that one. I milled both of these, or one side of this. One side was already the manufactured side, the other side I just milled to fit. Then the ends I cut with a bandsaw. Then I just went ahead and sanded it until it just fit in there and kind of rounded the corners. It fits pretty snug. I'm going to go ahead and use some contact adhesive whenever I put this piece in forever. And that should be enough of a pad so I can hang on to screws or anything that I don't want to damage, like maybe another piece of aluminum like this, so I can do filing or whatever I need to do and won't hurt it any. So here I am getting ready to stake the magnets. I'm going to use an automatic center punch to get it started. Then I'm going to wind up using just a flat punch to kind of stake it on over to make sure that it's not going to be able to leave. You can still hear it tapping a little bit, but that got it pretty much centered in the hole. So now I should be able just to smear this on over and keep it in there. And it looks like my magnet didn't survive very well. Yep. Okay. Okay. So there's that one. And these little guys will jump this little gap if they're not held into place very well. So there is one put together. Just like such. So what I'll do is I'll go ahead and finish up the other one. And what I'll probably do this evening is I'll go ahead and between the piece of Teflon here and the actual vise jaw cover, I will go ahead and put in the adhesive, contact adhesive, and crimp this vise closed with just a little bit of pressure and leave it overnight just to make sure that it adheres properly. Alright, there's the vise jaws all complete, ready to go. Magnets are all staked in, as you can tell. I've been using them already for a little project I had to do, holding small parts. But they work really well, they stick really well, they stay on the vise. I don't have any issues with them. It's a fun little project, so I hope you enjoyed it. You can always find more of my projects on Facebook under my name, Stephen Pranger. If you like my show, please subscribe, give me a thumbs up, and we'll see you next time. Thanks for watching. Okay, just one quick thing here before we get started on the milling machine. I want to show you exactly how we cut a pocket, or the measurements for a pocket. So this piece right here represents our block. So you've got this area here we're actually looking at here and here. So I want to mill this section out to put in this piece of Teflon. So how do we come up with numbers? Okay, for all of you that are not used to running milling machines, this is how we're going to do it. And for those of you who already do, then just fast forward through this section. So this corner is what we're going to go off of, that'd be this corner right here. We're going to do this as our datum point, our starting point. So we use an edge finder to find the edge of this material, and whatever edge finder you're using is up to you. I'm going to use a 1/2 inch diameter. So I find this edge, I move the edge finder 250 thousandths over because I want the spindle center line right on the edge of this material. On here and here. That way when I go to 0, 0, my corner is my spindle center line. That's what we're going to work from for the rest of this. So the material itself is 3 inches 580 thousandths. Now this section I'm leaving behind, this little edge, is 50 thousandths. So I'm going to take 50 thousandths off of each side. One side here, one side here. So that leaves me with an overall measurement of 3 inches 480. Now to cut my length, what I will do in math wise is I will move spindle center line, and I'm using a 3/8 inch diameter cutter, so that's what this math is based off of. So we'll move spindle center line over to pocket center line plus another 187 thousandths 5/10. That puts me just inside this section right here. So I know where my cutter's at. Now to move spindle center from this location to this location without running into my wall and leaving my 50 thousandths behind, I will take the distance of 3 inches 480 thousandths, 3.480 minus 3/8 of an inch, since that's the diameter of the cutter I'm using. So my total movement from here to here in the x-axis will be 3 inches 105 thousandths. That brings me from the cutter edge to this wall to the cutter edge of this wall. And you repeat the process the same way for this area of the pocket. This distance to this distance. So this distance here, let me find it, $950 thousandths minus, that is minus, so it's actually an inch 50, I'm sorry. So 1 inch 50 thousandths from this edge to this edge minus 100 is 950, because we're taking away 50, taking away 50, so that's minus 100. Now from when I place the cutter here, I want to bring it over to here. That distance traveled in the y-axis is the same. So it's 0.950 minus 0.375 gives us a distance of 575 thousandths in the x-axis. The rest of it is just cutting. Depth we already know. That's going to be 90. So I'll plunge the cutter in this corner, travel down 90 thousandths, and I will make a cut this direction. Then I'll come back, go back this direction, come up, and take out the middle. So 3 passes, 1 depth for that pocket. That will be on the milling machine next.